Okay. The topic of today's lecture is decision support expert system, their usage in medicine, and other related question until even topics related to modern topic related to artificial intelligence. So let's check agenda. First of all, we'll take a look into definition of decision support systems, their application in medicine, then take a look over expert system and artificial neural networks as some required backgrounds for running all modern AI solutions. Okay, move into, and of course, before we will talking about decision support systems, we will make short recap, and I will remind you definition of information system in generally, then definition of decision support systems, their taxonomies or classification, introduction into architecture, and so on. Again, we already spoken about information systems. That's combination information technology, people activities that supports operation, management, and decision making. And so I also already shown for you this chart, which made an emphasis that it's important to understand an information system as combination, not only hardware, software, but also networks and data and peoples who obligated to use this system in their daily basis, daily workflow. And again, within a range of different type of information system, this according to this classification, here is shown, as you can see, selected and surrounded two areas which emphasize goals of today's lecture. So systems dedicated to perform decision support system and providing expert advice, including artificial intelligence systems. They belong to that second at the bottom group, even if not referred explicitly. So, two different definitions. As you can see, first of all, take a brief look into history. Two definitions. 55 years ago, it was nothing spoken about computers, but model-based set of procedures for processing data and judgment to assist managers in decision making. And about 30 years ago, it was formulated modern vision of decision support system, which basically left unchanged up to these days. Interactive, flexible, adaptable, computer-based information system developed for supporting solution of non-structured management problems for improved decision making, etc., etc. So with some minimal variation, we have same definition of DSS system up to today, up to current day. So if you will take a look at modern definition, it's computer-based information systems that support business organization decision-making activities. So here is we are. And here we have major points like interactive, flexible, discovery-oriented, and accessible. So those meanings, those understandings left almost entirely unchanged for recent 30 years. And here is difference between management information system and decision support system, emphasized when on the internal section, management information system, it's only dedicated to create some reports, visualization, and so on. Here is decision support system, external components dedicated to also provide some entire recommendation, but still final decision has to be made by human manager. And the difference between like more selective, precise difference between management information system and decision support system. So would be again, as I already mentioned previous lecture, don't make misconception between Management Information System, MIS, and same abbreviate for Medical Information System, which we already spoken, and we'll again back to it into next question of this lecture. So where is Management Information System? Oriented to provide some information about performance organization, decision support system, and their descendant like expert system and so on. They provide information to analyze and techniques to analyze specific problems. In this case, MIS represent periodic and exceptional reports when the DSS provide interactive inquiries in response. Also, DSS oriented to different adaptable, ad hoc, flexible data format when MIS they are working in specific data sets. And DSS again, they oriented toward processing information with analytical model of different business data when MIS they are mostly oriented toward the extraction and manipulation of like basic analysis of business data. So speaking of classification or taxonomies of DSS, so again, it will be slightly different depending to source you will use, depending to textbooks, lectures, etc. We can use model of assistance as criteria. So here is we will have communication-driven, data-driven, document-driven, knowledge-driven, model-driven DSS, for example. We can use another access in other criteria like relationship with user, and then we will have passive active cooperative DSS. So those who can only provide the recommendation, who can provide some explanation, and with cooperatives that allow decision making, modify, complete, refine decision, provide perform continuous dialogue. In this case, cooperative DSS actually much more closely similar to not only expert system, but even modern AI chatbots, with only difference that classical DSS again oriented towards specific problem, unlike modern AI chatbot, which could be used for wide range of questions. So here is only difference in technologies, 2 years. If we back to previous definition, I just a little bit omitted. Here is a few important notice about previous classification by model of systems. That's communication drivers support more than one people versus not shared task. In fact, online collaboration platform like Teams, etc., considered as example of communication-driven CDSS because they support decision-making process, so that they fulfill definition of decision-making process. Data-driven, model-driven DSS. So here is in data-driven we emphasize that access and manipulation, the time series of internal company data, and model-driven emphasize access to manipulation of statistical financial presentation simulation model. So in this meanings, we can make model-driven DSS based on some, for example, statistical analysis techniques in Excel spreadsheet. But in the, it's absolutely correct. But in this case, it will be not only model-driven DSS, but it will be also spreadsheet document-driven DSS as well. And so here is this two different definition, two different approach in a visual form, model and data-driven. And in case of data-driven, we have data mining techniques or OLAP techniques, which visualize data in so-called OLAP cubes. Okay. So as I already mentioned, document-driven DSS that's dedicated to manipulate and structure information in a variety of electronic format. So we can consider any solution starting from Google Drive and up to NoSQL MongoDB database like this one, and they all will fall under the definition of document-driven DSS. And model-driven, knowledge-driven DSS, in some case, a little bit similar to model-driven DSS, again, provided specialized problem-solving, aspires towards fact rules, procedures, similar structures. So, in actually key difference that, again, model-driven concentrate toward some numerical models, for example, statistical models, so when knowledge-driven means that it's concentrate mostly on fact and rules and some other strict definition. But actually, again, in further lecture components, I will show that in case of medical solutions, they both very, very closely and usually combine it together. And finally, last approach to classification DSS, we can buy frameworks as they had been developed, text-oriented, database-oriented, spreadsheet-oriented. Yeah, that was example you were given during your practices. Solver, rule, and compound. All modern solutions usually compound, to be precise. Sorry. And finally, if you talk about architecture of DSS, it's usually shown here is general representation shown at the top and some more picturesque visuals shown at the bottom. Usually we have two data and model management component, which both integrated with user interface management component and fulfill interaction with user, like provide some dialogue and demonstrate results reports for user. So obviously data management components store information which could be derived from organization traditional data repositories, from external source, on from different personal insights, for example, manager administration, model management, presentation of events, facts, situations, etc. And as I already said, user interface is responsible for perform interaction with user. Then it was before I was shown very simplified structure of DSS, and here is like snapshot of one of real example how it could be composed and from which components. So usually it's a complicated system. Okay, so obvious benefits of usage of DSS: improving personal efficiencies, expanding problem solving, facilitating interpersonal communication, promotion, leading, training, improving decision quality, etc., etc., etc. So we can, it's out benefits, general benefits. Actually, real benefits depend to effectiveness of its usage, because sometimes it may happen that organization have implemented many DSS expert system, but because of some issues, for example, they used very poorly, and as in final effectiveness, it's very low. So it's every time we have to keep in mind human factor. Okay, now move into usage of decision support system in medicine. So some check about some specific types which used in healthcare area, like digital dashboard, CDSS, and more specific solution. But before it, check about like modern approach, which consider moving healthcare area into knowledge-driven healthcare area and provide knowledge-driven feedback from for making decision support through data aggregation of different clinical cases. And here is shown some areas of activities and as well as kind of medical data which could be processed through a clinical decision support system in order to facilitate more effective decision making, creating better, create more accurate diagnosis and create better treatment plans. So, okay, speaking about practical solution, first of all, digital dashboard. Enterprise dashboard is a board, so-called business management tool used to visualize certain status or health of business enterprise via key business indicator. Here is given different general definition, of course, not only related for medicine, but next, available few solution which is specially dedicated to be used in medicine. In my personal opinion, those system, it's not clearly a decision support system. I would rather classify it as a management information system, but most of sources which I have studied consider these systems as CDSS. So I will follow this. And here is we have, for example, medical management analytics. Again, there is clearly referred to analytical software, but anyway, we have visualization of on that database in our clinical or hospital repository. Usually mostly related to some performance index, quality assurance, not exactly to clinical cases. But again, so here is again, yes, I want to make emphasis that it's very often more cover different administrative issues and administrative questions of running a healthcare facility, but still it might be helpful to visualize some, to identify some tendencies and issues which it is related to performance of this particular facility or area. If it's used, for example, executive administrative in like in Ministry of Health or so. But it's not the only one solution. What is for me interesting, even more interesting, that's another digital dashboard, which is created not as dedicated application as previous case, but made of by using Microsoft Power BI. So here is given link, and through presentation you can check this link by yourself. That's again, we have this one dashboard a little bit more never, and as you can see, it demonstrates some situation related to relatively recent COVID pandemic. Again, here is in this case we have a tool which made of by like general analytical software, Power BI, and utilize some available healthcare data set. So, encourage you to check by link and get more information about this solution. From there comes major definition of major benefits of usage of digital dashboard, like visual presentation of performance, elimination of duplicate data entry, ability to identify correct negative trends, for example, measure for efficiency and inefficiencies, and so on. Ability to generate detailed reports showing new trends, etc. So, if you want to summarize it in a very short way, that's just remind my lecture on statistics. Most natural way for humans to retrieve information, it's visual representation. So if we have ability to visualize our data, it's much more comfortable, much more easy for us to get some insights from that data. Okay, now move into second type of medical DSS, clinical decision support system. Those are interactive computer programs which designated to assist physician in order to heal or other professionals with decision-making task or diagnostical task in this case. And actually, they are intent to improve healthcare delivery by enhancing medical decision with touching clinical knowledge, patient information, and other health information. So, we have two relatively modern definition for what is this actually. And when we talk about modern CDSS architecture, it every time have to be based on existing EHR solution. Look at the right side of this slide. So we should have some clinical database. We should have electronic medical and health records to be able to use power of the DSS inference engine, which use health records terminology and user input combine them with CDSS rules, and then execute decision support logic and provide some recommendation, decision, proposition about current patient state or accept new updates from physician. So we have some rules and guidelines obtained from different sources usually. It's actually and which is stored in form of knowledge base. So again, as I already from previous slide, it should be obvious. We have three major components: knowledge base, inferencing mechanism, and connection to or user interface. And yes, what is important to understand that it's modern time clinical decision support system actually almost cannot be distinguished from expert system. So they are very, very closely built up together. And if you will take a look about some abstract architecture of clinical decision support system, it's shown at left side, which actually we have. So what we have difference from general DSS architecture. In this case, in case of clinical DSS, we always have both model management and knowledge management component. This both must be present in CDSS, unlike general DSS. And practically, as I already mentioned, those systems always had to be built at the top of existing EMR, EHR solution. Moreover, very often they modern EMR EHR solution contains embedded CDSS. So CDSS being included as part of EMR software. Here is a small notice about how model component, how model core of CDSS could be developed. It's every time based on studying of some clinical data from clinical data cohorts, then generating, proposing mathematical model which will summarize our clinical data, speaking about what actually kind of analysis we want to perform. Is it, we talk about some special patient evaluation, laboratory results, some data registered from patient and so on. So we have to end up with some mathematical model, like how it will be formed in, or based on statistical analysis, and we got some CDSS rules, or we will apply something like regressional analysis and retrieve formula to simulate and make prediction. And then we have to evaluate model by using that right side out of sample population, which will be used for verification. Again, in all this case, we know our outcome, we know our conclusion, and only after evaluation, validation of model, and adjusting it could be used for treatment of new patient. So here is again also important point that this process again is the same in case of expert system and modern AI as well, because again there is no significant difference from user view side. And here is given one of potential scenario of implementation CDSS into healthcare practice, which is already implemented and already used in many cases. In this case, we are talking about generating clinical alerts in case of some potentially dangerous states of patient, and usage of CDSS together with telemedical activities which allow performing home monitoring, home surveillance of patient with some long-term critical illness. So they are point one of this chart, where data being collected into central repository and processed through CDSS. In case of abnormalities it being recorded, will be generated some emergencies, that's parts 2 and 3, then immediate emergency condition notes has to be generated, sent to physician to make the assessment, to provide or some remote telemedical contacts, or even if necessary, it's has to be deployed some emergency unit for hospitalization or so. But also that's, I mean, about step 4. But in other parts, it's providing case analysis and improving rule bank itself, improving knowledge base itself. So I mean, in this case, 5, 6, and 7 interaction. So in this case, it could be used for immediate assistance, but also it's very useful in case of data analysis and even up to medical education. So both these are useful scenarios. And as I will talk about examples, I already admitted that it's very often could be embedded into existing EMR solutions. So here is one of possible how it could be look like. We have exactly CDSS elements labeled, which provide some recommendation based on already available information in patient record. Okay, yet another case, free open source OpenEMR solution, which have components covered clinical reminders, but in fact, it's exactly the same things. It's exactly the same things. It's exact CDSS component, just under another name. So embedded and now standalone, because again, by definition, it could be flexible, interactive system, and so on. So here is another solution, medical algorithms project, which service which provide the physician access to huge number of evidence-based clinical calculators, decision support tools. Again, could be considered as CDSS, could be considered as even expert system as well. Borders very tiny right now between these two categories of systems. Long-term project, very successful. The only unfortunate situation that they almost completely commercialized now and almost no free content there. But it's also, in fact, indication of success. So generally, they have thousands of calculators. So how do they use term? But in fact, it's DSS, which organize it into categories. So again, physician already should have some preliminary decision, and with help of this CDSS tool, it's possible to like confirm, reject suggestion, or improve it. So each calculator very have fine documentation, clear reference to original information, some what is models, which rules had been used to provide outcome or recommendation. So that's the reason how we can verify tool. It's not unique project. There is number of concurrent solution. But here is the way how we can validate their reliability. It's every time have to provide reference documentation. They must refer necessary components, necessary documents, publication, textbook, articles, and so on. Now, a few words about one of possible approach to development CDSS or even expert system, MLM, medical logic model. This technology had been proposed already decades ago, but it has moderate popularity. Moderate. Not very wide, not very rare, but usually concentrate on some specific enterprise solution. In fact, what is MLM? Independent unit in health knowledge base. That's combined knowledge required, and the definition of the way it should be applied for single health decision. So it's like combine few rules and outcome from these rules. An idea of this model is that they could be shared between different clinical decision support systems. So they had been composed in very high-level programming language. It's called ardent syntaxes. And if few systems support that syntaxes, supported interfaces, so such MLM software modules could be shared between those systems. Definitely had been standardized under STM standards, and now it's part of HEALS Level 7 international standards. But as I already said, it's have moderate usage, moderate popularity. Here is example of practical solution. Software used to analyze of abnormalities in ECG signals had been written. This particular example had been written in Java. So again, it's very enterprise solution, modern time. How MLM examples, how MLM look like. So here is its example of MLM code, which designated to make decision about to calculate only a creative clearance from every time during collection. So here is given how we have structures, what operators had been used, and as you can see, it's a very high-level programming language, which is as close to natural English as possible. Because it's actually dedicated to be used by physicians. And even available some software development tool like integrated development environment and even solution which allow to host Ardent modules in kind of online service which could be utilized by external EMR solutions. So again, you can check by link this infrastructure. The only disadvantage is it's only commercial solution, and actually it's not cheap. It's not cheap. It's actually very costly, $1,000 for IDE, despite it based on free open source IDE, but say adaptation to support MLM that allows them to make it commercial. Okay, so here is a little bit already maybe outdated data, but still it's clearly show potential and development of CDSS market. And again, it's made emphasis on what is actually areas of activities and major achievements we have here. And as you can see by colors, what is primary objective, what is primary effective from usage of CDSS. So drug allergy alerts, drug-to-drug interaction, and clinical reminders. So here is major points where it have to be used, which already used and got some effect. Okay, now move into third question, expert system definition. So first of all, take a look into architecture of expert system, then some advantages, disadvantages. As I already said, it's very hard to distinguish, in fact, expert system from decision support system in modern time. Again, computer program that contains knowledge and analytical skills of one of more human expert related to a specific project. So starting development historical points actually about the same as for clinical decision support system, latest 1960s, beginning of 1970s. The only aim is different if CDSS designated to assist professional decision making, so expert system theoretically designated to replace human expert and provide final solution for non-expert user, for ordinary user. So here it is. Like and for already many years, I joked for students that you will compete with physician in smartphones. Actually, it's already in place, almost, because mostly we have legal limitation on this diagnostical like software diagnostical solution, legal, not technical. General architecture of expert system very similar for this in case of clinical decision support system. We have knowledge base, inference engine, user interface, and again knowledge base often rule-based, so contain list of rules which determine what should be done in different situations. And each rule has two-part condition action pair, which is actually exactly what you had tried with your spreadsheet task recently, like if-then rules. If-then rules. So again, expert system in this case, very similar for two spreadsheet drive and CDSS. Difference, as I already said, in purpose. And those differences have to be validated by some legal permission rather than technical solution. So obviously we have example how we made condition, how we can use logical function, which kind of logical function, if and or not, so the same things we can combine, and how we can create this expert system rules. So working memory contains contents of working memory constantly compared to production rules, and contains much condition of rule fire action execute. And if we have more than one rule might be much working memory, so then it will be run in cycles, so each matched rule being added to the conflict set, and then each conflict has to be resolved in some sort of way, but by the other rules available into knowledge base, and the cycle will be repeated upon all conflicts will be resolved, and as outcome we must come to some single solution. So in addition to already available, already explained components of expert system, here we this chart made emphasis on two extra necessary components. So first of all, in order to have an expert system, we should have domain expert, which has to be capable to summarize knowledge from particular area, and that knowledge must be processed by specific staff, knowledge engineers, whose job is to perform formalization. Yeah, exactly, formalization of information, knowledge obtained from domain expert in order to present it in knowledge base. So that's, yeah, of course, creating those ifs and else rules. And system engineers, which is responsible for designing system in general and combining together all components. Okay, I already made emphasis about role of knowledge acquisition and role of knowledge engineers. So they are responsible for fields that's consistency of data loaded, and so on. Okay, example of expert systems. So here is an example of algorithms. One of the way it's use flowchart to represent algorithm. Here is we have flowchart to make diagnosis about, to make decision about type of diabetes. So as you can see, even in this case, we have relatively complicated flowchart, but it's still one of the most easiest cases to visualize. It's still possible to manage this like manually by hand. So when we have some diagnostic algorithm, and when we have proper description, which could be turned into flowchart and represent one-way direction for made final decision. Okay, another working solution, Munich that's for health markets. So again, this one mostly not a diagnostic, but actually administrative solution. Risk care and risk management in healthcare market. And yet another interesting project, IBM Watson project, which capable answered question proposed in natural language. So everybody now for already a few years about ChatGPT, but not many people know about that it's not a fast solution in this area. And if we talk about practical solution, if we talk about again commercial solution, Watson was available on market a decade before ChatGPT. So it's actually they had been started to be used to be implemented into medical healthcare data analysis, data processing since 2012 officially, and it was possible to obtain commercial access since 2014. If I not make nothing, don't make mistake. So the initial idea were to improve quality of diagnostic and treatment plans for cancer treatment. Gain idea were to combine different data sources like the patient medical records available, previous historical cases available, information, medical information like textbook articles, different information about updates in pharmacy development, and so on, and with aim to again improve objective. As you can see, health position, clarify information, patient medical records, and suffice relevant evidence and explore treatment options with aim to create personalized treatment. So that was initial project for initial Watson for oncology series. So here is key features. As you can see, extract attributes for patient records, so analyze existing EMR, then provide evidence-based treatment recommendation using available sources, evaluate current case against current domain knowledge in area of oncology, of course. So, and here is, that's hundreds of medical journal textbooks, billions of pages of text had been processed and incorporated into their knowledge base. And final aim, it was patient-centric insight, so creating personalized treatment solution. That was aim of project. So how it was look like for some quite period of time, very specific. In this case, nothing very different than usual EMR record, EMR software, sorry. But still, it's not exactly EMR software. It's patient medical record accessed through Watson for Oncology paths. And with here some data analysis and recommendations. So here is, in this case, we have two concurrent treatment option, like recommended for consideration, as you can see labels, with some difference. So still, in this case, it's something, again, we have overlap of terminology and even more overlap in marketing targeted. Because if we have this choice, meaning that professional could make choice, that's meaning that it could be like clinical decision support system. But IBM itself sold this project not even as expert system, but even on the terminology of artificial intelligence. So in this case, it's actually hard to distinguish what actually has to be considered. Where do we have actually CDSS expert system or artificial intelligence? Because it's very different things considered under these terms if we talk about technical expertise or marketing positioning. Later, they tried to extend area of usage of this technology and not only limited by HEALS, but encourage to use it within financial solution, Internet of Things, education, media, advertising, etc., etc. So they try to find more way to utilize their achievements, their technology. Unfortunately, as you can see, 2 years ago, say less than 2 years ago, 1.5, they were completely divested. So it's like fast commercial application had started in 2015, but that end up sold in 2020, and it was completely shut down 2023, unfortunately. Again, it's not means they was working wrong. It's very successful technological solution, but their model of sales fail. So here is simple marketing solution, not technology. It's marketing fail, not technology fail. So it was just unable to solve their SAS, system as service. It was available via subscription. So the hospitals have to subscribe and share their data with standardized protocols, but it means they not achieve expected sales, volume of sales. Okay, so here is shown. We can summarize potential advantage, disadvantage of expert system, but just don't want to read and repeat all this. As I already pointed, speaking of IBM Watson project. All these things, it's more about successful marketing. If it was be possible to solve it effectively, so that will be success. As a case, even if it's technologically very advanced and very effective solution, it will help very high risk it's to fail this product. Okay, now a little introduction into artificial neural network, which is essential background for all modern artificial intelligence solution. Again, I will speak not about AI itself, I will speak about artificial neural network. Definition, model, learning, and some application, including most prominent. So, when we talk about artificial neural network, we have to understand it's mathematical model, computational model, which is based on biological neural network. It consists of interconnected group of artificial neurons that process information using connectionist approach to computation. So in most cases, then it's adaptive systems that changed its structure based on external or internal information that's flowed through the network during learning phase. Generally, we describe input, what we have to supply to ANN. We describe to learning phase, we describe noun output. So if we input some set of value, we should retrieve this. And we define some initial parameters of this network, like some basic its characteristics. Then we run corresponded INN algorithm, which build up internal structure of INN. So, and in fact, initially, internal structure is unknown and it's limited by parameters, but not like researcher or developer. It could be seen like this one. First of all, INN had been developed through learning phase, when we have some learning data set with noun input parameters and noun output. And then we have to define limitation for hidden node layer, which is not defined and unknown for the moment. Так, then aim of neural network models designed to emulation of central nervous system in mind, subject of theoretical neuroscience. Так, modern software implementation of analytical neural networks, the approach inspired by biology has more or less been abandoned for more practical approach based on statistics and signal processing. So, NN models essentially simple mathematical models defining a function where function f from x defined as composition of other functions g of x, which can further be defined as composition of other function. So it's might be not one level of GI, but GI1, GI2, and so on. And it can be fundamentally represented as network structure with arrows definite variables. And widely used type composition, nonlinear weight and so on. So FIX type what function we use as instead of G1, where occurs some predefined functions such as hyperbolic tangent or some others. And actually, we can represent it as simply a vector of G from 1 to n, where n could be, in modern time, n could get to billions. So in modern time, those sum could be extremely large. And here is we can now depict our structure in form of weighted sum. So we have decomposition of f, which dependence between variables and weekend variables. So here is we have function of u input x transformed three-dimensional vector h with then transformed two-dimensional vector and we transform it into f, where under x we have our input, under f our expected output. Again, expected, I mean, we are talking about learning stage. We are talking about case when we know relationship between input and output. And when we move from functional to probabilistic view, we can represent a variable f, which is equal to f out of g, when we have random variable g, which is depend to many g function and which depend to some h function and which depend to random variable x. So in this case, we talk about two layers of artificial neural network with two internal layers. H and G, it's internal layers of ANN. But again, in reality, number of these layers not necessary to be limited. So we could have much more layers, and actually we can construct much more layers, and actually number of layers in modern NN solution, no, they are limited only by computational capabilities for hundreds, thousands, like this, only this. And in this case, possibility of learning, when we have specific task to solve in class of function, f learning means using some observation in order to find some f star which belong to f capital, which shows that task is an optimal sense. And then the entire design and cost function. Cost function is an important concept in learning, which is measured how far away we are from an optimal solution problem we want to solve. And so with training neural network model essentially means that selecting the model from set of our models that minimize the cost criteria. So here is, we have component-based representation neural network, and it's kind of more general representation used by some neural network software. Again, in modern time, it's almost impossible to visualize a completely internal structure because number of the structure it's reached to thousands, so it's called epochs. Okay, practical usage, practical application of finance solution, it's of course approximation function, regression analysis up to different time series prediction, modeling, classification, including pattern sequence recognition, meanings, automatic analysis of images, novelty detection, and etc. And of course, one of the most important application, it's possibility to create, to perform text, the natural language processing and text recognition and analysis. So, but before this, like two examples, pattern recognition. So here is again given links that you can utilize and try this. For example, an NN solution designated to identify abnormalities with X-ray images. And here is at the bottom shown some logical points which incorporated into this model in order to obtain solution. So Yet another example from this set, which is again show how neural network could be used for segmentation of medical images and in order to identification possible tumors in brain based on MRI scan in this case. So, of course, what is main problem that like unfortunately different models has to be used in case if you want to analyze or if it will be X-ray images or if it will be MRI images. Those artificial network must be learned in different way. As a result, their internal structure will be different, and we can't use INN network-based trained to identify X-ray anomalies. We can't use it to identify, for example, brain tumor or other oncologist issues. It has to be retrained, and it will be another NN model. So the only limitation. And in both cases, we need very quite significant computational power to store our learning data set and to train model itself and run it. And of course, one of the prominent outcome of artificial neural network studying achievements is ChatGPT. Large language model that's developed by OpenAI, launched at the end of November of 2022, then upgraded a few times already. It's based on so-called transformer architecture developed by Google initially, proposed by Google initially, but available for like description and major idea already for free, and then tuning for conversational application using knowledge supervised and reinforced learning techniques. So, as I already mentioned, few upgrades have been made for this model. It's right now not only working with text input, but can process images, even audio input, and commercial solution video content. So what is important is process of learning of model. Here is given reference to their public website, which contain information about model itself, which is more spoken about in InstructGPT, which is background for ChatGPT, and here is spoken, and here is noted about what is most important for understanding its size of training data set. When we have some billions tokens, under tokens, we understand some child sequence. It could be words or part of words. And it was only for for already outdated GPT-3 model. With modern model, a number of token increased a few times already. So here is also shown how reinforced learnings had been used for creating some outcome, creating some conclusion. And again here, the document shared by OpenAI, which is explain how they perform supervised and unsupervised learning with human response. how that's being processed. And idea of tokens. So here is how do they can manage by their inputs. So any of prompts we writing with this tool, it's the same. It will be, in this case, it's no difference. It talk about ChatGPT or other modern counterparts like Tam or Gemini, Grok, Copilot. They all utilize the same techniques, the same technology right now. Tokenize input, tokenize prompt. So here is at the bottom shown with different color, shown each token, and even the same color represent not the same token, represent usually different token. So here is we have, in this case, it's very rough assessment because in modern case, they even separate words by consorts, and we have much more tokens within our prompt than all these tokens being compared with model obtained from few learning steps in order to predict expected set of tokens, which practically will be a response to this prompt. And actually, response is amazing. It even was very early, my very ear attempt to make some question about some retrieve some database in ChatGPT in different language. So that actually was amazing and even improved right now. Significantly improve right now. But in case of attempts to implement one large language model for medical diagnostics, it's not not everything as clear and bright, because here is we spoken about very specific cases. So LLM working very fine when we need some general answers on general meanings, but when we come to very narrow specific problems, usually they fail. And here is clear demonstration when some physicians have tried to evaluate capabilities of LLM in case of diagnostics. So in this case, system detects that VDR with bones fracture, but exact type of fracture was identified incorrectly. This case almost correct, but not exactly. But in case if here is it was attempt to analyze X-ray image, so conclusion had been made was very unclear and still required some discussion, as you can see, debatable here. Takes. No, again, as we are already close to the end of the lecture, so what we have to expect? That these things, this citation I have selected from one of the first article which had been published almost immediately, very soon after the release of ChatGPT. So first of all, cautions. Usage of LLM will require careful consideration to ensure safeguards are in place to protect against potential dangerous use by past expert medical advice. So, author, as you have reference, so you can access this article if you want. Authors have significant cautions about to wide usage smartphone doctors instead of visiting human experts. And but still careful optimism with constructive regulatory environment, emphasis on regulation, emphasis on law and orders. The real-based language model could have transformative impact healthcare, augmenting rather than replacing. So, in this case, we are not talking about true AI. Sorry. It's even hard to talk about expert system. It's still CDSS. It's still CDSS. Augmenting rather replacing human expertise. But ultimately improving quality of life for many patients. So I agree in this case, and actually nothing significantly changes since this 2 years after release of this system. Despite we have more and more interesting observation, more and more interesting tries, for example, general performance in SMOE, but soft skill assessment only, not hard skill. So only in this part of SMOE, yeah, results very good, but not in hard skill. And even we have solution which could assist medical students. So number of this case, number of usage already available, but again, I am actually excited, but not absolutely impressed. Not absolutely impressed because all my personal experience with ChatGPT, it's very moderate. If I don't know nothing about that specific area, this tool could provide nice introduction, but if I need very specific answer, it's very hard to obtain something useful from there, and sometimes it's take too much time to create prompts with a huge number of failed answer. Okay, that's actually all I want to present for you for today. Thank you for your attention.